removed everything related to work from my personal computer. But here's the twist, I can still access everything very quickly. I put Proxmox on my old desktop and it hosts my dev, Kali and storage VMs. On an old laptop I have every vulnerable machine. Everything is physical and everything is behind pfSense on separate VLANs. So in this video I'll show you everything step by step. So let's get to it. Here is how it's laid out. My personal PC and my husband's PC, the one called Marcelo PC, stay on the admin side. Then the desktop runs Proxmox, and inside Proxmox I will host the dev VMs that my husband uses to test and deploy code, the Kali VM which I use for penetration testing, and the storage VM where I will store files, images and videos. Now I created the storage VM outside of my personal computer so I can push files and videos to it and my husband can access them without touching my personal PC. Finally, I have an old laptop that will only run vulnerable machines inside VirtualBox. These are disposable targets that I can break safely. Now that you've seen the whole layout, let me show you the gear that I used. So, first of all, and this is totally optional, I will use a power line adapter set. So my ISP router is located in my living room and my office is in another room, so I will use a power line adapter set to extend the internet connection to the office without running a long internet cable through the house. Next, I will also use a pfSense router, and this is the physical firewall and router that protects the whole setup. I will also use a smart switch, and this is what actually separates the networks physically. So a smart switch lets you assign ports to specific VLANs and carry multiple VLANs on a trunk port. I will be using one old laptop and one old desktop, so one will be used for Proxmox and the other for the vulnerable machines. So I'm using a whole computer for the vulnerable machines because it's safer than having those on Proxmox together with our other VMs. I will be using also Ethernet cables. I will also use one HDD hard drive disk. This is because I need more space on my Proxmox for the VLAN and for the storage VLAN. Lastly, I will use a USB stick with at least 16 GB or more space would be better. And we will install Ventoy on this USB drive and store all the bootable ISOs that we will need, such as Proxmox, Ubuntu and Kali. With the gear clear, let's talk about all VLANs that we will create. So here's the plan. So we will create VLAN 10, that will be the admin VLAN, and this will have my computer, my husband's computer and the switch. So this is for management only. Then we will create VLAN 20 and this will be Proxmox's VLAN. Inside of Proxmox VLAN we will have another 3 VLANs. VLAN 30, VLAN 40 and VLAN 50. So VLAN 30 will be our dev VLAN and this will be composed by VMs on demand. Meaning if I need 2 VMs for a specific work, then I can create those VMs and in the end I can delete them and so on. Then we have VLAN 40, which will have our Kali VLAN. In this VLAN we'll have a VM with Kali installed. This VM will be used to hack vulnerable machines. VLAN 50 will be our storage VLAN, where we will create a VM where we will store files, images, videos, etc. Lastly, we will have VLAN 60. This VLAN is our vuln VLAN. So this will be on my old laptop and it will have installed VirtualBox. Now we will create every vulnerable VM inside of VirtualBox and we will hack those VMs using our Kali VM. You probably won't need to build everything in this setup. So for example, if you don't share the files with anyone on your house, then you probably won't need to create the storage VLAN. So only build what you really need. Additionally, everything here in this setup will only be accessible from devices on your local network and that you have explicitly allowed. Okay, before we wire anything, let's make a multi-boot USB with Ventoy. So Ventoy is excellent because it turns a single USB drive into a multi-boot drive. That means you can keep Proxmox, Ubuntu and Kali on a single stick and choose what to boot. So no need to reformat the same stick every time we want a different OS. First, we download the Ventoy package for Linux from the official website. Next, we verify that the file hasn't been tampered with by checking its checksum. So to do that, we run the following command: sha256 sum in the name of the file. Then we compare the output with the sha256 value on the Ventoy download page. And if they match, we proceed. In my case, they are the same, but if that's not the case for you, then stop and re-download the file. Because if the values aren't the same, that means that the file was tampered with. Now we can extract the file, and to do that we run the command tar-xvf and then the name of the file. Okay, the file is extracted. Now we can plug in the USB. The system usually auto-mounts the USB, but we need the device name, so we must run the following command: lsblk-o name, path, size and mount point. We note the output and we remove the USB and rerun the same command. Now we compare the two outputs and the device that disappears is your USB. Now we can plug the USB back in and rerun the command. Now you know the name of the device, which in my case is the SDA device. The SDA1 is a partition of SDA. However, note that Ventoy needs to be installed on the whole device, which is SDA, not on the partition, so not on SDA1, and write down the name of your device as you will need it later when we install Ventoy onto it. Now, before proceeding, ensure that you don't have any crucial files on the USB stick, as installing Ventoy will erase everything on it. Okay, let's move on. On our terminal, we need to change into Ventoy's directory. Then, by listing its contents, we see a lot of different files that we can use to install Ventoy. However, the one that we will use will be ventoy2disk.sh. This is because, as the name says, this script installs Ventoy onto a disk, which in our case is the USB stick. Now we are ready to install Ventoy, and to do that we can run sudo ventoy2disk.sh -i dev sda. Let me just explain the command so you can understand it. Sudo, as you know, because we need root permissions. // will execute the file. ventoy2disk.sh it's the file. -i stands for install. Dev sda it's the full disk where we will install Ventoy. Here you need to pull out the note you made of your device's name and use it in the command. Let's run the command. We confirm with a Y and we confirm again with a Y. And it's done. Now we just need to drag and drop the ISO files onto Ventoy USB drive. I already have the ISO files that I will use on my computer, but if you download them, always make sure they come from the official source and haven't been tampered with. With the USB drive ready, let's move on to the pfSense box and begin the hardware setup. Okay, the first thing that we need to do is to plug an HDMI cable from a screen into the pfSense device so we can see the configuration menu. We also plug in a keyboard because we need it for the initial setup. Then we can power on pfSense computer and wait for it to boot. So, to the question, should VLANs be set up now? We say no. Now we assign the interfaces. So, for the WAN we use IGC0, for the LAN we use IGC1, which will connect to our switch, and we also assign the remaining ports, so IGC2 and IGC3. Now, we will not use them right away, but if we ever want them later, they are already assigned. Now we proceed. And at this point, pfSense has assigned an IP address to the LAN, but not to the WAN. And that's because no Ethernet cable is currently connected to it. Now, once we connected the cable, pfSense will automatically assign an IP to the WAN. So let's connect the cable. Now we need to reboot the system, and to do that we choose option 5 and we say yes, and we wait a little bit. Now after rebooting, as you can see, we have IP addresses for both WAN and LAN. Before we continue, let's take a moment to understand how all the pieces of our network work together. The WAN is pfSense's connection to the outside world, in our case the ISP router. That's how internet traffic comes in and goes out. The LAN by default is one big flat network. That means every device can see and talk to every other device. In our setup, that's not secure enough, because we don't want our Proxmox server, our vulnerable machines and our personal computers all mixed. Instead of a single flat LAN, we use VLANs, and VLANs enable us to divide the LAN into multiple logical networks, each with its own subnet, gateway and set of rules. For example, we have one LAN for our computers, another for Proxmox and the third for the vulnerable lab. Then we have the switch as a key role, so it doesn't provide internet and it doesn't make firewall decisions. Its job is to tag and untag VLAN traffic so that pfSense knows where the traffic originates. Now to make this work, we need a smart or managed switch. So a smart switch allows us to assign VLANs to each port, enabling pfSense to keep all networks separate and because of that secure. Okay, let's move on. The next step is to change our LAN's subnet. Currently, both the WAN and LAN are on the same subnet, and pfSense does not allow this because it causes routing conflicts. At this stage, it doesn't matter much what subnet we assign to the LAN because this is temporary. So, once we create VLANs in pfSense, the LAN port will cease to be a single flat network and will instead function as a trunk, carrying all the VLANs we configure. So, let's do it. Here we choose option 2 from the menu to set the LAN's IP. We enter 2 again for LAN, and to this question we say no because we will set the IP manually. Now we will enter the IP for LAN. I will use 192.168.2.1. The subnet will be 24. To this question, to the gateway question, we just press enter because pfSense will be the LAN's gateway. To the question configure IPv6 address LAN interface via DHCP6, we say no. And because we said no to the previous question, here we don't type anything, we just press enter. Do you want to enable the DHCP server on LAN? We say yes. We want pfSense to automatically assign IP addresses to the devices that we connect, so this way when we plug our PC into the switch, it immediately gets an IP in the new subnet. Now we enter the start address of the IPv4. I will enter 192.168.2.100. Now we enter the end address of the IPv4, which will be 192.168.2.200. To the question, do you want to revert to HTTP as the web configurator protocol? We say no, and this is because we want to keep HTTPS. Now we press enter to continue, and done, guys. And now we can connect the smart switch to the LAN port of the pfSense device. Also, we can connect our personal computer, the one that we will use to manage everything, to the switch. Now, at this stage, we need to ensure that our computer is actually communicating with pfSense over Ethernet. We run IPA, and as you can see, the computer's IP address is now 192.168.2.100, which is inside the DHCP range we set. That means communication works. Since the computer can communicate with pfSense, we can open a browser and log in into pfSense. So let's do it. Here we click next, next again, we leave pfSense as host name, and for domain I will write Sobatista Cyber. Below, let's uncheck override DNS, and this is because if we leave this checked, pfSense will use your ISP's DNS, which is often slower, less private, and sometimes even filtered. So by unchecking it, we can choose faster and more secure DNS servers, such as Cloudflare or Quad9. Now we click next, then leave the time server host name as it is and change the time zone to your own click Next. Where it says RFC 1918 networks, uncheck block private networks from entering via WAN, and this is because our pfSense WAN is sitting behind the ISP's router, which assigns a private IP address to pfSense. If we leave this box checked, pfSense will assume that any private IP address on the WAN is suspicious and will block it, including the one from our ISP router. And if pfSense blocks that, it blocks its own internet connection. On the Configure LAN interface page, leave it as it is, click Next, enter a new password for admin, never use the default password. And before we proceed, we need to check if there are any updates to be made, and as you can see, there's none. Now, because we unchecked DNS override in the wizard, pfSense won't use the ISP's DNS. That means we need to decide which DNS servers to trust. Now, pfSense can resolve everything on its own, but for extra reliability and malware protection, we should add trusted providers like Quad9 and Cloudflare. So let's add those. We go to System, General Setup. Now let's add first Quad9, and we use 9.9.9.9 and we write dns.quad9.net. We also add 149.112.112.112 and we write dns.quad9.net. Now we add Cloudflare, and the first will be 1.1.1.2 and we write security.cloudflare-dns.com and we also add 1.0.0.2 and we write the same, security.cloudflare-dns.com. Now we make sure that DNS override is unchecked, which is, and we save the changes. Now we also should enable DNS over TLS to encrypt our queries. This way our ISP or anyone sniffing packets can't see the domain names we query. So to do this, we go to Services, DNS Resolver, we scroll to the DNS query forwarding section and we enable forwarding mode. By doing this, pfSense will forward all DNS queries to the servers we just listed, so the ones from Cloudflare and Quad9. We also enable SSL TLS for outgoing DNS queries, and this is because we want to encrypt our queries. We save and we apply the changes. Now, this yellow warning is about ISCDHCP end of life. This isn't an error. pfSense is just telling us that ISCDHCP will be removed in the future, so let's fix this now. And we change to KEADHCP and we save the changes. Finally, we test the internet access through pfSense, so we disable Wi-Fi and we use the Ethernet, and it should work. Now let's create our VLAN tags. Okay, so let's go to Interfaces, Assignments and VLANs. Now we add the tags and we need to add every tag on our LAN, not on our WAN, and this is because the switch will be connected to the LAN. We name our tag and the first tag that I will name will be 10 and we add a description. In this case I will name it admin because it's where I will manage everything, and we save. We add our second VLAN, so we click on add, the name will be 20 and the description will be Proxmox, and we click save. We add our third VLAN, the name will be 30 and the description will be dev, and we save. We will add another VLAN. This time it will be 40, the description will be Kali, and we save it. Let's add another one. The tag will be 50 and the description will be storage. Let's save it. And the last VLAN that we will create will be the VLAN with the tag 60 in the description vuln. We save. And that's it. Okay, we have our tags, but now they need to be assigned as interfaces. We do this because creating VLAN tags just makes labels, but assigning those tags to interfaces is what turns them into real networks in pfSense. So to do that, we go to Interface Assignments. Here we have our WAN, LAN and the other physical ports that we didn't use. So we can delete them and add our VLANs. But don't worry, because this doesn't break anything. Nice! Now let's add our VLANs. We just need to choose the VLAN and click Add. Okay guys, now we need to enable each VLAN, so add its IP address and its corresponding subnet. So to do that, we can click on the first VLAN, which is located on OPT1. We check enable. As a description, we add admin, since I chose OPT1 to be my admin. Let's set IPv4 configuration to static IPv4. We won't use IPv6, so we don't touch it, and we scroll down. We add our IPv4 address, so 192.168.10.1. The subnet will be 24 and we click save and apply the changes. Now, if you go to Interface Assignments, you will see that we no longer have OPT1, we have admin. Now let's move on to the next VLAN. So we click on OPT2, we check enable. As description, we add proxmox. Let's set IPv4 configuration to static IPv4, and as IP we write 192.168.20.1. The subnet will be 24. We save and we apply the changes. Now let's go back to Interfaces, then Assignments, and let's enable OPT3. We check enable. As description, we write dev. Let's set IPv4 configuration to static IPv4, and as IP we will write 192.168.30.1. As subnet, we insert 24. We click save and we apply the changes. Now let's go back to Interfaces, then Assignments, and let's enable OPT4. We check enable. As description, we write Kali. Let's set IPv4 configuration to static IPv4. As IP, we write 192.168.40.1. The subnet will be 24. We save and we apply the changes. Now let's once again go back to Interfaces, Assignments, and then let's enable OPT5. So we check enable. As description, we write storage. Let's set IPv4 configuration to static IPv4. The IP will be 192.168.50.1. The subnet will be 24. We save and we apply the changes. And one last time, let's go back to Interfaces, Assignments, and let's enable OPT6. We check enable. As description, we write vuln. Let's set IPv4 configuration to static IPv4, and as IP, we will write 192.168.60.1. The subnet will be 24. We save and we apply the changes. And it's time to create our firewall rules. But before we do that, let's make our lives easier and create the aliases. To create our aliases, we go to Firewall and Aliases. Now we can create our first alias. Mine will be for my computer, so I will name it _cyber_PC. The IP will be 192.168.10.10, and this will be the IP that I will later configure on my computer. Now we save, and I will create another alias for my husband's computer, and I will name it Marcelo_PC. And the IP will be 192.168.10.11 and save. Now let's create another alias, this time for proxmox. So the name will be proxmox_MGMT, that stands for management, and the IP will be 192.168.20.10 and we save. We create another one for Kali and we will name it Kali_VM. The IP will be 192.168.40.10 and we save it. We now create another for dev VMs, so the name will be dev_VM and these will have a range. So we'll begin on 192.168.30.50 and on 192.168.30.99. So as you can see, the range goes from 50 to 99. I created this alias works this way because the VMs that we will create on the dev VLAN will have an IP inside of this range. Now we save it and we create another one for storage, and we will name it storage_server, and we give an IP of 192.168.50.10. We save, we create another for the vulnerable VMs, so we can call it vuln_VMs. In this one will have also a range, so it will begin on 192.168.60.50 and on 192.168.60.99, and we save. Lastly, we will create another alias that we will call of RFC1918. Now we change to networks and we enter 10.0.0.0/8. We add another one, 172.168.1.6.0 in the subnet 12, and we add another IP that will be 192.168.0.0 in the subnet will be 16, and we save and we apply the changes. Nice, the aliases are set. Now it's time to create our admin's VLAN rules. So, to create our rules, we go first to firewall, then rules, and then we click on admin because it will be where we will apply all the rules. Also, be sure that the order of the rules that you set are the same as mine because pfSense will apply the rules from the top to the bottom. So let's begin. We can click on one of these two buttons. It doesn't really matter now because this will be the first rule. I will click on this one. Now the action will be pass. The interface you already know is the admin. The address family is IPv4. The protocol is TCP. On the source we choose address or alias, and we will choose the alias that we created for our computer. In my case was sobatista_cyber_PC. On the destination, we choose address or alias once again, and we will choose the proxmox alias that we created. In my case was proxmox_mgmt. Now we need to add a port, so in this case is 8006 in both fields, and we give a description. In my case I will say allow Sobatista PC to access Proxmox graphical user interface. Now, let me just tell you that Proxmox management runs on HTTPS on port 8006. So this rule will allow our computer to access Proxmox over HTTPS on that port. Now we save and we create our second rule. This time we will add the rule to the bottom. The action will be pass, the interface is admin as you know, the address family is IPv4, the protocol is TCP, on the source we choose address or alias, and in my case I will choose the alias that I created for my husband's computer, which is Marcelo_PC. Now you don't have to add this rule if you don't have another computer accessing the Proxmox interface. Now on destination we choose also address or alias, we choose our Proxmox alias, and on the port we write 8006 on both fields. Now as description I will give allow Marcelo's PC to access Proxmox GUI. Now you already know what this rule does. Basically it's allowing my husband's computer to access Proxmox graphical user interface. Now we save, we add the rule to the bottom. Now the action will be pass, the interface admin, address family IPv4, the protocol TCP. These are already the defaults. Now on the source we choose address or alias, and we choose our alias, the one for our computer. On my case is Sobatista_cyber_PC. On the destination we choose also address or alias, but this time we choose the dev alias. So in my case was dev_VM. Now because I want to access the dev VMs using my computer, I will add the port 22, which is SSH. So basically I will use SSH to work on the dev VMs from my computer. Now on the description, I will write allow Sabatista PC to access dev VMs via SSH, and we save. Let's add another rule to the bottom. The action is pass, interface admin, address IPv4, protocol TCP. The source will be address or alias. In my case, I will choose my husband's alias, which is Marcel_PC. The destination will be also address or alias and dev_VM. The port will be SSH. Again, in the description will be allow Marcelo PC to access dev VMs via SSH. So basically, I created a rule like the previous one, but this time for my husband. And we save. Let's add another rule to the bottom. So the action will be pass, interface admin, address IPv4, in protocol TCP. On the source, we choose address or alias, and we will write the alias of our computer. On the destination, we choose once again address or alias, and we choose the dev alias. Now, on the destination port range, we choose VNC, which is port 5900, and on the description, I will write allow Sabatista PC to access dev VMs via VNC. Basically, this rule allows graphical remote access from our computer to the dev machines, and we save. And we do the same for Marcelo's PC, so let's add another rule to the bottom. The action is pass, interface admin, address IPv4, protocol TCP. The alias will be Marcelo on the source. On the destination, we choose address or alias, and once again the dev VMs. The destination port range is VNC once again, and on the description we write allow Marcelo PC to access dev VMs via VNC, and we save. Let's add another rule to the bottom. Where it says edit firewall rule, we leave it as it is, everything, the action, interface, address, and protocol. On the source we choose address or alias, and we will add the alias of our computer. On the destination we choose once again address or alias, but this time we choose the Kelly alias. Now on the destination port range we choose VNC, which is port 5900, and the description will be allow Sabatista PC to access Kali via VNC. And you already know what that means. So it means that I will be able to use my computer to access Kali using VNC. Then we save. Let's add another rule to the bottom, but this time the action will be blocked and the protocol will be any. On the source we choose address or alias, and I will choose my husband's alias, which is Marcelo_PC. In the destination will be Kali subnets. On the description I will write block Marcelo PC from accessing Kali subnet. Well, this description says it all, so I'm blocking my husband's PC from accessing my Kali VM, and we check the logs. Now we save. Now let's add another rule to the bottom. The action will be pass, the interface is admin, the address is IPv4, the protocol TCP, the source will be address or alias, and we will choose our computer alias. The destination will be address or alias once again, but this time the alias will be the storage alias, so in my case storage_server. In the destination port range will be SSH, which is port 22. Now on the description I will write allow Sabatista PC to access storage VM via SSH, and we save. Now I will do the same for my husband, so I will add another rule to the bottom. The action will be pass, the interface admin, address IPv4, protocol TCP, the source will be address or alias, and the alias will be Marcelo_C. On the destination I will choose address or alias once again, and the alias will be storage_server. The destination port range will be SSH, so port 22. In the description will be allow Marcelo PC to access storage VM via SSH. Now we save. Let's add another rule to the bottom. The action will be pass, the interface admin, address IPv4, protocol TCP. On the source we choose admin subnets. On the destination we choose this firewall. The destination port port range will be DNS53. Now, as description, we can write allow admin VLAN to use pfSense DNS over TCP. Now let me just explain that this rule allows the devices on the admin VLAN to use pfSense as their TCP DNS resolver, ensuring larger responses succeed while keeping name lookups local and controlled. Now we can save. Let's add another rule to the bottom. So the action will be pass the interface admin, the address will be IPv4, and the protocol this time will be UDP. On the source we choose admin subnets, the destination will be this firewall. The destination port range will be DNS, so port 53. In the description will be allow admin VLAN to use pfSense DNS over UDP. Now let me just explain this. So this rule allows devices on the admin VLAN to use pfSense as their UDP DNS resolver, keeping the name lookups local and controlled. Now we can save. I know guys, these are a lot of rules, but we are almost done for now, of course. So let's add another rule to the bottom. So the action will be block the interface admin address IPv4, but this time the protocol will be any. The source will be admin subnets, but the destination will be vuln subnets. Now we check the log. In the description we will write block admin VLAN from accessing vuln VLAN, and we save. And we will add another rule to the bottom. The action will be block, and the only thing besides the action that we will change will be the protocol, and we change it to any. The source will be admin subnets, and the destination will be address or alias. And the alias that we will choose is the RFC 1918 alias. We check the log. In this description we can write block admin VLAN from reaching all private networks. Now let me just explain it. So we block admin devices from reaching all private networks, hence the RFC 1918 alias, to prevent lateral movement and accidental access. Now this rule denies all RFC 1918 addresses by default, but if we add a specific allow rule to the top, so above this block rule, that allow overrides the block and gives admin machines access to that exactly IP or service and nothing else. So think of this as a safety net, where explicit allows take priority and everything else stays blocked. Now we can save it. Let's add another rule to the bottom. The action will be block, change the protocol to TCP UDP, the source will be admin subnets, the destination will be any, in the destination port range will be 53, so DNS. As description we can write block direct DNS from admin VLAN to the internet. Force DNS through pfSense. Now let me explain this very quickly. So this rule blocks any direct DNS queries from the admin VLAN to the internet, forcing admin machines to use pfSense as their DNS resolver. So in short, our machines can talk to public DNS servers directly. They must ask pfSense, which lets you filter, log and control all name lookups centrally. Now we check log and we save. Now let's add our last rule, for now of course, to the end. So the action will be pass, the protocol will be any, and everything above it will stay the same. On source we choose admin subnets, on the destination we choose any, and as description we can write allow admin VLAN to access the internet. So this rule is what will give us internet connectivity, and it needs to stay always on the bottom. So this must be always the last rule. Now we can save and we can apply the changes. Now, before we continue adding the rest of the rules, we need to configure the switch because it doesn't know how to carry the VLANs yet, and we need to instruct it accordingly. Currently, pfSense is capable of sending multiple VLANs through its LAN port, but the switch, by default, doesn't understand those VLAN tags, so we need to teach it how to handle them. So first we need to know our switch's IP, and to do that we can click on status and then DHCP leases, and here you you should have your switch's IP. Now here's mine, so I will copy the IP and go to Google and write the IP. Now we enter the default credentials. Usually you can know your default credentials on those installation guide papers that come with the switch, so you enter those, and in my case TP-Link prompts me to change the current default password, so I will change it, then I will confirm it, and we are in. Now let's create our VLANs on the switch, and to do that we go to VLAN and we click where it says 802.1q VLAN, and as you can see currently our switch is set to disable. That means that it's behaving like an unmanaged switch, but as we already know, we need it to act like a managed switch, so we need to enable it, and to do that we click where it says enable, then apply, and we say OK. By doing this we can see that a table has been provided to us, which we will use to define our VLAN IDs. Now by default this switch already has a VLAN 1, but this can't be deleted, and currently all traffic is flowing through it. However, once we create our own VLANs and assign the ports to them, VLAN 1 loses its role and no traffic will pass through it anymore. Before we begin adding our VLANs, let me explain you something. On a switch, a port can be set as untagged, tagged, or not a member of a VLAN, as you can see here. Now let me explain that. The switch will manage all the traffic of every VLAN that we specify. The traffic that reaches the switch can be tagged or untagged, and if it's tagged, the switch knows immediately which VLAN it belongs to because it's tagged. Now, if it's untagged, then the switch uses the PVID of the port to determine where the traffic should be directed. So the PVID is just the default label that the switch assigns to all untagged traffic arriving on that port, indicating which VLAN to place it in. By default, some devices can't read tags. Now, when this is the case, we untag the port of that device. Now, when you have devices that can read tags, we set these ports as tagged. Lastly, we have the not member. For each VLAN, the ports that we don't mark as tagged or untagged will be marked as not member. This is because these ports won't be used at all. So let's begin. We can guide ourselves by using pfSense because we already created our VLANs there. So we can go to Interfaces, then Assignments, and finally VLANs. There we have the VLAN tag in description, which we will need. Let's add our admin VLAN on our switch. Now where it says VLAN ID, we add our admin's VLAN tag, which is 10, and where it says VLAN name, we add the name, which is admin. Below we have all the ports on the switch. Now we tag port 1 because that's our uplink to pfSense, and we untag ports 2 and 3 because those belong to devices in the admin VLAN. Now port 2 is for my computer and port 3 is for Marcelo's computer. Port 4, 5, 6, 7 and 8 are set to not member because they do not belong to the admin's VLAN. And we click add, and our admin VLAN will appear on the table below. Now we add Proxmox VLAN. So the first part you already know. We do the same as we did for the admin's VLAN, so we give the ID and the name. As for the ports, we will always tag port 1 so we can have a connection to pfSense. Now Proxmox, which is my desktop, will connect to port 4 of the switch, so we untag that port. The rest of the ports stay set to not member because, as I told you before, they do not belong to Proxmox's VLAN. And we click add. Now let's add the dev VLAN, and as you can see here on pfSense, the dev VLAN has an ID of 30 and the name is dev. So let's add those to the table. Now we tag port 1, and because this VLAN will be inside Proxmox because it's a VM, we also use port 4. But this time we tag port 4 because this VM can read tags. The rest stays set to not member, and we click add. Now let's do the same for Kali VLAN. As you can see on pfSense, this VLAN has an ID of 40 and the name is Kali, so let's add those. And this is the same as we did on our previous VLAN, so on the dev VLAN. So we tag port 1, and because this VM, so the Kali VM, will be inside Proxmox, we also tag port 4 because this VM can read tags. Then we click on add. Now let's add our storage VLAN, and this will be the same as we did for Kali and dev. So the ID will be 50 and the name is storage. Port 1 will be tagged and and port 4 will be tagged as well. The rest will stay as not member. And we click add. Now we add the vuln VLAN. The vuln VLAN has an ID of 60 and the name is vuln. Now we tag port 1 and we will untag port 5. The rest stays set to not member and we click add. Finally, we will create a VLAN with an ID of 99, which we will use as a dump VLAN for unused ports, because as you can see, we didn't use port 6, 7 and 8. We make this VLAN because this way, these ports can't be used unless we say so. So we untag ports 6, 7 and 8 and the rest stays set to not member. Now we don't touch VLAN 1, which is a default VLAN because the switch requires it. Now for every untagged port, we assign its PVID, so the switch knows to which VLAN the untagged traffic belongs. So let's do it. We go to 802.1q PVID setting and ports 2 and 3 get PVID 10 for the admin, port 4 gets PVID 20 for Proxmox, port 5 gets PVID 60 for the vulnerable VLAN, and ports 6, 7 and 8 get PVID 99. Now we don't do this for the tagged ports because those already carry VLAN tags and don't need a PVID. After this, we should change the IP of our switch. So let's change the graphical user interface to our VLAN 10. So we go to System, then IP settings, then disable DHCP. On the IP address, we enter 192.168.10.2. The subnet will be 255.255.255.0 and the gateway will be pfSense, so 192.168.10.1. We apply and say OK. Now, if you look at your URL, you can see that the graphical user interface is on our admin VLAN. Now, as you can see, we lost our connection with the switch because our computer's IP is still within the LAN, not the admin VLAN. So we can finally change the IP of our computer from DHCP to a static IP inside the admin VLAN. We will lose Ethernet connectivity for a while, but that's not a problem because after we change the IP, we will receive Internet connectivity. So since VLAN 10 is admin, we set our IP to 192.168.10.10. The net mask will be 255.255.255.0. The gateway will be 192.168.10.1, which is pfSense, and the DNS will also be pfSense, so 192.168.10.1, and we apply. And as you can see, we now have internet connectivity, and if we go back to the switch's graphical user interface, we can connect to it. And going back to pfSense's graphical user interface, we can also connect to it. Well, this is amazing, guys. Now, on pfSense, if we go to status, then DHCP leases, we can see that our computer and our switch still get an IP from DHCP. That's because when we initially configured our LAN's IP, we enabled DHCP. So our computer could receive an IP from the LAN and access pfSense's graphical user interface. But we don't need it anymore, and we can disable that. So we go to Services, then DHCP Server, and we click on LAN. Now we can uncheck Enable DHCP Server, then we save, and we apply the changes. Now that we have set things up for admin VLAN, we need to make sure that everything is really working. To make sure pfSense is also routing properly, let's test outside of our network by using the ping tool. So we will ping the IP 8.8.8.8. So this will send 3 packets to this IP. So let's see. And it works, no packet lost, and this means we have internet connectivity. Next, we will ping google.com. This test isn't about internet connectivity, but about DNS resolution. And it works. It means that pfSense is resolving domain names into IPs. Now let's verify the route that our packets take. We need to ensure that our packets are going through the switch, hitting pfSense first, and only then leaving our network to reach the internet. So to do this, we can use traceroute 8.8.8.8. And as you can see, the first one is our gateway that tells us the traffic is flowing correctly from our computer through the switch into pfSense. After that, we will see our ISPs routers and then other devices on the internet until we finally reach Google's DNS server at 8.8.8.8. Finally, let's check which devices are directly connected to us on our local network. For that, we can use ARP-A. So it shows the MAC addresses of the devices our computer is directly communicating with. And this one is our switch. This one is our pfSense. In the switch is configured, we've done everything needed for the switch to work. So let's add the rest of the rules. The first rule will be added to the top, so the action will be pass, the interface is admin, address IPv4, protocol TCP. Now on the source you will choose address or alias, and we will choose our computer's alias, in my case it's sabatistacyber_PC. On the destination we choose this firewall, so self. In the destination port range will be HTTPS, so port 443, because as you can see in the URL, pfSense uses HTTPS. Now, on the description, I will write allow Sabatista PC to access pfSense GUI, and we save. Now we will add our second rule also to the top. The action will be block the interface admin, the address will be IPv4, the protocol will be TCP, the source will be admin subnets, the destination will be this firewall, the port HTTPS, and as description we can write block admin VLAN devices from accessing pfSense GUI. Now we can save and we will move the block rule to the second place, because if we let the block rule at first place we will blocked from pfSense. That's it for admin. Let's move on to Proxmox. Okay, now we can click on the Proxmox tab, and before we begin by adding our rules, let me just tell you that this time I won't explain any rules from now on, because these rules are the same as the ones that we added on our admin VLAN. So if you have any questions, please go back in the video, see the explanation that I gave for each rule, and if you still have any questions, please leave those in the commentary section down below. So let's begin by adding a rule to the top or to the bottom, it doesn't really matter because it's the first rule. So the action will be pass, the interface is Proxmox as you already know, the address is IPv4, protocol TCP, on the source we choose Proxmox subnets, on the destination we choose this firewall, and on the destination port range we choose DNS, which is port 53. Now on the description we can write allow Proxmox VLAN to use pfSense DNS over TCP. Then we save and we add another rule, but this time to the bottom. The action will be pass, then we will change the protocol for UDP, the rest above will be the same, the source will be Proxmox subnets, the destination will be this firewall, the destination port range will be DNS, so port 53, and we will write on the description allow Proxmox VLAN to use pfSense DNS over UDP, and we save. Let's add another rule to the bottom. The action this time will be block, the protocol will be TCP UDP, everything above will stay the same, the source will be Proxmox subnets, the destination will be any, on the destination port range we will choose DNS, which is port 53. We check the log, and as description we can write the following: block direct DNS from Proxmox VLAN to the internet, force DNS through pfSense. Now we save and we add another rule to the bottom. The action will be block, everything below will stay the same, on source we choose Proxmox subnets, the destination will be this firewall, the destination port range will be HTTPS, below we check log, and the description can be block Proxmox VLAN from accessing pfSense GUI, and we can save and add another rule to the bottom. The action will be block, the protocol will be any, everything above stays the same, the source will be Proxmox subnets, the destination will be admin subnets. We can check the log below, and we can write on the description the following: block Proxmox VLAN from accessing admin VLAN, and we can save, and we can create another rule and add it to the bottom. bottom. So the action will be block, the protocol will be any, the source will be proxmox subnets, the destination will be dev subnets, we check the log, and as description we can write block proxmox VLAN from accessing dev VLAN. We save and we add another rule to the bottom. The action will be block, protocol will be any, everything above stays the same. On source we choose proxmox subnets, on destination we choose Kali subnets, we check the log and we can write on the description the following: block proxmox VLAN from accessing Kali VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be proxmox subnets, the destination will be storage subnets, we check the log and we can write on the description block proxmox VLAN from accessing storage VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, everything above stays the same, the source will be proxmox subnets, the destination will be vuln subnets, and this rule is very important, guys. We can check the log and on the description we can write block proxmox VLAN from accessing vuln VLAN. We save and we add another rule to the bottom. The action will be block, protocol any, everything above stays the same. On the source we choose proxmox subnets, on the destination we choose address or alias, and the alias that we will choose will be the RFC 1918. Now we check the log and we can write on the description the following: block proxmox VLAN from reaching all private networks. We save and we add another rule to the bottom. This time the action will be pass, however the protocol will be any, everything above stays the same, the source will be proxmox subnets, the destination will be any, and we can write in the description the following: allow proxmox VLAN to access the internet. We save and we confirm every rule and we apply the changes. And that's it for proxmox. Next we will insert our dev rules. So we can click on the dev tab. Now you can click on one of the add buttons. I will click on this one. The action will be pass, the protocol will be TCP, the source will be dev subnets, the destination will be this firewall, the destination port range will be DNS, which is 53. On the description we can write allow dev VLAN to use pfSense DNS over TCP. We save and we add another rule to the bottom. So the action will be pass, the protocol will be UDP, the source will be dev subnets, the destination will be this firewall, the destination port will be DNS, which is port 53. On the description we can write allow dev VLAN to use pfSense DNS over UDP. We save it and we add another rule to the bottom. This time the action will be block, the protocol will be TCP UDP, the source will be dev subnets, destination will be any, the destination port range will be DNS, we check the log and we write the following description: block direct DNS from dev VLAN to the internet, force DNS through pfSense. We save it and we add another rule to the bottom. The action will be block, protocol will be TCP, everything above stays the same. On the source we choose dev subnets, on the destination we choose this firewall, on the port range we choose HTTPS, we check the log and we write block dev VLAN from accessing pfSense GUI, and we save and we add another rule to the bottom. The action is block, protocol is any, everything above stays the same. On the source we choose dev subnets, on the destination we choose admin subnets, we check the log and we can write on the description block dev VLAN from accessing admin VLAN. We save it and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose dev subnets, on destination we choose proxmox subnets, we check the log and we can write on the description block dev VLAN from accessing proxmox VLAN. We save and we add another rule to the bottom. The action is block protocol any. On source we choose dev subnets. On destination we choose Kali subnets. We check log, and on the description we can write block dev VLAN from accessing Kali VLAN. We save and we add another rule to the bottom. So on the action we choose block protocol any. On source we choose dev subnets. On destination we choose storage subnets. We check the log, and on description we write block dev VLAN from accessing storage VLAN. We save and we add another rule to the bottom. The action is block, the protocol is any. On source we choose dev subnets. On destination we choose vuln subnets. We can check the log and we can write the following description: block dev VLAN from accessing vuln VLAN. We save and we add another rule to the bottom. The action is block, the protocol will be any, the source will be dev subnets, the destination will be address or alias, and we will choose the alias RFC1918. We check the log and we can write on the description block dev VLAN from reaching all private networks. We save and we add another rule to the bottom. The action will be pass, protocol will be any. On source we choose dev subnets, destination we choose any, and we write on the description allow dev VLAN to access the internet. We save and we can apply the changes. So these are all the rules for dev. Now let's jump to the Kali VLAN. Let's add our first rule. So the action will be pass, the protocol will be TCP, everything above stays the same. On source we choose Kali subnets, on destination we choose this firewall, and on the destination port we choose DNS. On description we can write allow Kali VLAN to use pfSense DNS over TCP. We save and we add another rule to the bottom. So the action is pass, protocol this time will be UDP, the source will be Kali subnets, the destination will be this firewall, the destination port will be DNS, and on the description we write allow Kali VLAN to use pfSense DNS over UDP. We save and we add another rule to the bottom. This time the rule will be block, the protocol will be TCP UDP, the source will be Kali subnets, destination will be any, the destination port range will be DNS. We check the log and we write block direct DNS from Kali VLAN to the internet and force DNS through pfSense. We save and we add another rule to the bottom. The action will be block, the protocol will be TCP, the source we choose Kali subnets, on destination we choose this firewall, the destination port is HTTPS. We check the log and we write on the description block Kali VLAN from accessing pfSense GUI. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be Kali subnets, the destination will be admin subnets. We check the log and we add on the description block Kali VLAN from accessing admin VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be Kali subnets, the destination will be Proxmox subnets. We check log and we write block Kali VLAN from accessing Proxmox VLAN. We save and we add another rule to the bottom. The action is block, the protocol any, on source we choose Kali subnets, on destination we choose dev subnets. We check log and we write on the description block Kali VLAN from accessing dev VLAN. We save and we add another rule to the bottom. This time the action will be pass, the protocol will be any, on source we choose Kali subnets, on destination we choose vuln subnets, and on description we write allow Kali VLAN to access vuln VLAN. We save and we add another rule to the bottom. This time the action will be block, the protocol will be any, on source we choose Kali subnets, on destination we choose storage subnets. We check log and on description we write block Kali VLAN from accessing storage VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose Kali subnets, on destination we choose address or alias, and the alias that we will choose will be RFC1918. We check log and we write on the description block Kali VLAN from reaching all private networks. We save and we add another rule to the bottom. This time the action will be pass, the protocol will be any, the source source will be Kali subnets, the destination will be any, and we write on the description allow Kali VLAN to access the internet. We save and we apply the changes, and that's it for the Kali VLAN. Now let's jump to the storage VLAN. Let's add our first rule. The action will be pass, the protocol will be TCP, on source we choose storage subnets, on destination we choose this firewall, on the destination port we choose DNS, and we write allow storage VLAN to use pfSense DNS over TCP. We save and we add another rule to the bottom. Now the action will be pass, the protocol will be UDP, the source storage subnets, the destination will be this firewall, the destination port will be DNS, and we write allow storage VLAN to use pfSense DNS over UDP. Now we save and we add another rule to the bottom. This time the action will be block, the protocol will be TCP UDP, and the source we will choose storage subnets, the destination will be any, the destination port will be DNS, we check the log and we write block direct DNS from storage VLAN to the internet, force DNS through pfSense. We save and we add another rule to the bottom. The action will be block, the protocol will be TCP, the source will be storage subnets, the destination will be this firewall, the port will be DNS, we check log, and the description will be block storage VLAN from accessing pfSense GUI. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be storage subnets, the destination will be admin subnets, we check the log and we write on the description block storage VLAN from accessing admin VLAN. We save and we add another rule to the bottom. The action will be block, the protocol any, on source we choose storage subnets, on destination we choose Proxmox subnets, we check the log and we write block storage VLAN from accessing Proxmox VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose storage subnets, on destination we choose dev subnets, we check log and we write on the description block storage VLAN from accessing dev VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose storage subnets, on destination we choose Kali subnets, we check log and we write on the description block storage VLAN from accessing Kali VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose storage subnets, on destination we choose vuln subnets, we check log and we write on the description block storage VLAN from accessing vuln VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, on source we choose storage subnets, on destination we choose address or alias, we will choose the RFC 1918 alias, we check the log and we write on the description block storage VLAN from reaching all private networks. We save and we add another rule to the bottom. The action is pass, protocol TCP, on source we choose storage subnets, on destination we choose any, the destination port will be HTTP, which is port 80, we check log and we write on the description allow storage VLAN outbound HTTP. Now let me just tell you that this rule in the next one will give only the essential internet access so we can update our system. We save and we add another rule to the bottom. So the action will be pass, the protocol will be TCP, the source will be storage subnets, the destination will be any, but this time the destination port will be HTTPS. We check log and on description we write allow storage VLAN outbound HTTPS. We save and we apply the changes. Now we can move on to the vuln VLAN. Let's add our first rule. So the action will be block, the protocol TCP, the source vuln subnets, the destination this firewall, the destination port range will be HTTPS. We check the log and we write on the description block vuln VLAN from accessing pfSense GUI. We save, we add another rule to the bottom. The action will be block, the protocol will be any, the source will be vuln subnets, the destination will be admin subnets. We check the log and we write block vuln VLAN from accessing admin VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be vuln subnets, the destination proxmox subnets. We check the log and we write on the description block vuln VLAN from accessing proxmox VLAN. We save and we add another rule to the bottom. The action will be block, the protocol any, on source we choose vuln subnets, on destination we choose dev subnets. We check the log and on description we write block vuln VLAN from accessing dev VLAN. We save it and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be vuln subnets, the destination will be Kali subnets. We check the log and on the description we write block vuln VLAN from accessing Kali VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be vuln subnets, the destination will be storage subnets. We check the log and we write block vuln VLAN from accessing storage VLAN. We save and we add another rule to the bottom. The action will be block, the protocol will be any, the source will be vuln subnets, the destination will be address or alias, and we will choose the RFC 1918 alias. We check the log and on the description we write block vuln VLAN from reaching all private networks. We save and we apply the changes. And this is all for the rules. Next, we will install Proxmox on a desktop. So the first thing that we need to do is to plug in the Vento USB and power on the device. Now, we need to enter the BIOS so we can select the USB drive as the boot device so the installer starts. Now by doing that we will see our Vento menu with all the ISO files that we put there. So we can choose Proxmox, then we choose boot in normal mode and we are directed to the Proxmox installer boot menu. Here we choose install Proxmox VE graphical. Now we have to agree with the license agreement. Here we select the hard disk where Proxmox will be installed, and before we move on, make sure that you don't have any important files or images on these drives, because once we install Proxmox everything will be erased. So we choose the target and we click next. We choose our location, time zone and keyboard and we click next. Then we enter a password and an email and we click next. We give a host name, but be aware that this is different from the other OSs like Ubuntu, Kali, because as you can see here on the screen, in the installer example, you see three parts separated by dots. The first part is the host, and for that I will use Sabatista Cyber. For the other two parts, we use home.arpa because it's the recommended namespace for home setups. So the full name is, in my case, sabatistacyber.home.arpa. Now here you can see I used a different one because I could only learn more about this after I recorded the video, so don't copy what I did, use .home.arpa. Next we give the IP of the Proxmox VLAN and that will be 192.168.20.10. The gateway and DNS server will be pfSense, so 192.168.20.1, and we click next. We confirm everything and we click install. As you can see here below on this bar, Proxmox is being installed, so we just need to wait a little bit. Now after this, Proxmox will reboot automatically, and after that we can access Proxmox from our computer at this IP on this port. So let's do it. HTTPS, then the IP that we gave to our Proxmox, so 192.168.20.10, and then the port 8006. Now your browser may warn the connection is not secure, but that's normal, so we click on advanced and we accept the risk and continue. And here is our login page. Now during the Proxmox installation you saw that we didn't define a username, and that's because Proxmox creates the system root account during the installation. So the username is root and the password is the one that we set while installing Proxmox. Now you have also the realm, and on the realm we have two options, the Linux PAM option and the Proxmox PVE. Now we pick Linux because the root account lives in the base OS and there are no Proxmox users yet, so the Proxmox authentication option won't work for the first login. Later we will create Proxmox PVE users, and those are the accounts that we will actually use for for daily work on the dev, Kali and storage VMs. Let's log in and we are in, guys. Okay, we have this pop-up, but this isn't a problem, so we can click OK. Now, Proxmox defaults to the Enterprise APT repository, which is intended for paying subscribers. So if you don't have a subscription, that repo will often return errors when you run package updates. Now, Proxmox itself is free and open source, and to get updates without a subscription, you switch the node to the community repository. It's a one-time change to the APT source files, and after that you can update the system without any problems. So let's do that. Let's make those changes. So, to know what files we need to change, we can go to Proxmox. Then, where it says Proxmox Virtual Environment, we click on Learn More. Then click on Get Started. And where it says Configure the host machine, click on How to Configure. And below, you can see the repositories in Proxmox. Now let's go back to our Proxmox and open a shell. So to do that, we right-click on Nodes and we click Shell. Now, if you list the contents of the directory sources.list.d and the full path is etc/apt/sources.list.d, you will find three files: the Ceph, the Debian and the pv-enterprise files. Now, if you go back to the website and you scroll down, you will see that the Debian repository remains unchanged, but the pve-enterprise in the Ceph repositories don't, so we need to change those from enterprise to community. So let's do that. First, let's change the PVE enterprise file. So if you print its contents, you will see that it's set to enterprise. Let me just bring up Proxmox's help page for this screen so you can see. So as you can see, the content that we currently have on the PVE file is enterprise. But as we continue to read, we can disable this enterprise content by commenting each line. So we do this because we do not have a subscription and therefore to prevent any errors. So let's edit this file: nano/etc/apt/sources.list.d/pve-enterprise.sources. So we comment every line, and then where it says no subscription repository, we copy all these and we paste on nano, and then we save the changes. Now let's do the same for the Ceph file. So we scroll down here on Proxmox's help page. As you can see here, we have the Ceph repository, and here below we have the no subscription info for the file. So we copy these, then we use nano, so nano/etc/apt/sources.list.d/ceph.sources. Now it seems that everything is commented, so we just need to paste the info and then we save the changes. And after this, we update the system. So let's see: apt update and apt-dist-upgrade-y. And well, it seems that it's working, everything is getting updated. Okay, it seems that everything is updated. Now we just need to reboot the system. So reboot now, and let me just tell you that it's very common to see connection closed on the shell, so you can go ahead and close the shell, and once Proxmox is ready to use, we can open a new shell and we will see connected. And it's time to create our dev, Kali and storage VLANs on Proxmox. But first, we need to make some configurations on Proxmox's network interface. So let's see the contents of the interfaces file. So cat etc network interfaces. Okay, so it seems that right now Proxmox is behaving as if it were a LAN, but as you know, we needed to split things into VLANs. So we need to manually tell Proxmox that it needs to be VLAN aware. Before we do that, we must create a backup of the interfaces file, so if anything happens, we can always revert things. So let's do that. cp etc network interfaces etc network interfaces.backup. Now, if you list the contents of the network directory, you will see that not only we have the interfaces file, which is the original one, but we also have the interfaces.backup file. And now we can do the changes. So let's edit the file with nano etc network interfaces, and we add these two lines. So the line bridge VLAN aware, yes, is pretty intuitive, and the second line tells Proxmox to carry tagged VLAN IDs from VLAN 2 to VLAN 4000 94. Basically every normal VLAN except VLAN 1. So I excluded VLAN 1 because it's the switch's default VLAN. So what we need to do now is reboot the system. So we run the command reboot now to apply these changes, and we can close this shell. Now our Proxmox is powered on again, so we can move on and create our VLANs. Our VLANs are created by creating the VM itself. Meaning, while we configure the VM, we will say that the VM belongs to VLAN X. So the first step is to copy the ISO file that we want to use to create the VM into our Proxmox storage. So for this, we can use the Ventoy USB, which already has all the ISO files that we need. Let's plug in the USB stick into Proxmox and run the command lsblk. Now, in my case, my USB is called SDB. Next, we create a directory where we will mount our USB. For that, we will use the command makedir mnt, where we will create the new directory, and the new directory will be called USB. Then we mount the USB in the directory with the command mount dev sdb1 on mnt USB. Now we mount sdb1 because it's the main partition where Ventoy and the ISO files live. Now, if we list the contents of mnt USB, we will find all the ISO files there. All we have to do now is copy them into the directory where Proxmox keeps the ISO files. To do that, we use the command cp mnt usb and then the name of the file. So the first one will be Ubuntu, and we will copy them into var lib vz template ISO. And don't worry, but this process can take a while. So now let's copy our Kali ISO as well. So cp mnt usb, then the ISO var lib vz template ISO. Okay, now let's confirm that both OSs are there. So L and S var lib vz template ISO, and there they are. Lastly, we can unmount the USB from the directory that we created. So let's use the command unmount mnt USB and remove it because we don't need it anymore. So rm-rf mnt USB. Now we can close the shell and confirm that we have indeed our ISO files by double-clicking on local storage, then on ISO images, and we should have both images there. Now, before we move on to create our VLANs and VMs, I need to add my HDD storage to my Proxmox desktop because I don't have a lot of storage resources on this desktop. So, if you need to add more storage now, it's the time to do it. Go ahead and connect the HDD storage to the Proxmox device. If it's not your case, then move on to the next part of this video. So for the ones who added HDD storage, open a shell and run the command lsblk-o name size type mount point. With this command, you should see your storage. In my case, it's this one. Next, we will create two partitions on the disk, one for the dev VMs and another for the storage VM. So let's do it. cf disk dev sdb. Now we delete the partition that exists and we create one with 250 GBs. So we click new, we give 250 GBs, click enter, and we choose primary. This created SDB1, which will be used for the VMs. Now, with the remaining space, we will create the second partition for the storage VM. So we go to free space, we click on new, and we let the default size. So this default is the remaining available storage. We click enter, we click primary, write, and quit. Now if you run the command lsblk, we will see two partitions. Next, we need to format both partitions. So let's format it. Let's use the command mkfs.ext for dev sdb1, and we will use the same command for the second partition. So instead of being 1 is 2. Then we create two mount points, one for each partition, so let's do it. Make dir mnt hdd-dev and another for the storage, so make dir mnt hdd-storage. Now we need to add them permanently to the fs tab file, so let's do it. Nano etc fs tab. On the end of the file we add these two lines, and by adding these to the file we are instructing the system to mount these partitions automatically on boot. Finally, let's run the command mount-a. This command mounts all file systems listed in the fs tab. And it seems that we need to reload the system, so let's do it. Okay, now we can run the command again, mount-a. And to confirm that everything worked, we run df-h pipe grep sdb. And it worked. Now, as you know, Proxmox runs on Linux, and the changes that we did were done on Linux. But now we need to tell Proxmox that these partitions are available to use. So to do that, we click on Data Center, if not already there, then Storage, add Directory, and as ID we give hdd-dev. This is just the name Proxmox will show. As directory, we provide the mount point we created for this partition, which was mnt hdd-dev. As a node, we choose the one we have and we click add. And we need to do the same to the storage partition. So add, then directory. As ID we give hdd-storage. As directory we give mnt hdd-storage, and as node we choose the one we have and we click add. And it's time to create the VLANs inside Proxmox. So let's begin with our dev VLAN. So as you know, this VLAN will be created to launch VMs in demand that are inside the range that we specified on Proxmox. So the range was from 50 to 99. However, right now, if we created two VMs, both would fight for the same IP address, and this would cause conflicts. This happens because DHCP isn't enabled in this VLAN. So for this to work, we need to enable DHCP on this VLAN. So in this way, when we create multiple VMs inside this VLAN, pfSense will know what IPs to give and which ones are already in use. So let's solve this problem. Let's go to pfSense, then Services, and then DHCP Server. There we will click on Dev, we click Enable to enable DHCP, and then we give the same range that we specified on the alias. So 192.168.30.50 to 192.168.30.99. Now we save and we apply the changes. And everything is ready to create our VMs. So let's go ahead and create our VM. In general, let everything as it is except the name. So give it a name like dev-image, then click next. On OS, leave everything as it is. Just choose the ISO image, then click next. On system, change the machine to Q35 because this is modern, faster, and works better with today's Linux. Change the BIOS to UEFI because it's faster and what modern PCs use. Now by choosing UEFI, we are asked to select the EFI storage, so here we can choose HDD-dev because this way all the VM's files are stored in the same place, which makes things easier to manage. Below we see pre and roll keys, so go ahead and uncheck that. I didn't do it because I forgot, but we uncheck it so secure boot stays off, ensuring Ubuntu boots smoothly in Proxmox without compatibility problems. Then on the right side we check QEMU agent. This feature is really useful because it allows Proxmox to communicate directly with the VM. I'm not installing the agent inside Ubuntu in this video, but by enabling this option now, we have already prepared the VM. So that means if we ever want to use those features later, we just need to install QEMU guest agent package inside the VM and we click next. Now on disks, we set disk size to 30. Now remember that this can be different for you. Everything else stays the same and we click next. On CPU, I will give 2 cores. For memory, I will give 4096. Now it's in the network tab that we specify our VLAN. So on VLAN tag, we use 30, then we uncheck the firewall, then we click next, we confirm everything and finish. As you can see, our dev image will appear here. Now let's power on this VM and configure it. So double click on the VM, then start, and then console. Now choose the language, click next. Here we click next, we select the keyboard, then next, we choose wired connection, then next, choose install Ubuntu, then interactive installation, and then next. Here click next, then choose erase disk and install Ubuntu, then click next. Now insert your info here, then choose your location and install. Now click on Restart Now. As you can see, it says that we need to remove the installation medium, which means that we need to remove the ISO file so the system can boot from the hard disk. So we click on Hardware, then CD DVD drive and Edit. From this list, we choose Do not use any media, then OK. If you go back to the summary, you can see the VM is still running. So let's stop the VM to boot it correctly. So we click on the drop-down menu, then click on Stop and we say yes. Now let's start the VM again. And as you can see, the VM is booting well. Now we are presented with this welcome prompt. So we click Next. On Enable Ubuntu Pro, we click Skip and here we select No, don't share system data and we click Next and Finish. Now let's see if our VM is within the range we specified for our dev VMs on pfSense. So we run the IPA command and it is, guys. Next, let's make our window bigger, and to do that we go to the settings, then display, and we select this measure. And lastly, let's update our system. So we go again to the terminal and we run the command sudo apt update and sudo apt upgrade -y. Then we run the command sudo apt auto remove and y. Okay, now you can install whatever you want on this VM. So after you install what you want, go ahead and shut down your VM. Now let's do something very nice, guys. That is, because I need to launch VMs on demand with the same setup, I will convert this VM into an image, which means that if I need like 3 VMs with the same setup, I just need to clone this image, which is very cool since we don't need to waste a lot of time setting up every VM we launch. So let's do it. We select the VM, click on the drop down on More, then Convert to Template, and we click Yes. So from now on, you can create all the VMs you want as long as your setup has the necessary specs. Now, be aware that you can't boot this image. This is just an image that you use to create the VMs. So I will show you how to use it. On Data Center, right-click on the image and click on Clone. Then you just need to give it a name and clone. Now let's create our hacking VM. We do the same as we did for the dev VM. So we click on Create VM. As VM ID, I will give it 200. As name, I will give it Kali, and we click Next. On the OS, we choose the ISO, then we click Next. On the system, we change the machine to Q35, the BIOS to OVMF. On the EFI storage, we choose the local-LVM. We uncheck the pre-enroll keys and we check QEMU agent. Then we click Next. On disks, we change the storage to local-LVM. The disk size will be 100, then we click Next. On CPU, we change the cores to 4 and we change the type to host. Then on memory, we change it to 16384, then we click Next. On the network tab, we enter the VLAN tag and that will be 40 and we uncheck the firewall, then we click Next, we confirm everything and we click Finish. Now let's start the VM and go to the console. So we choose graphical installation, we select the language, the location and configure locals. Then we select the keyboards, Now we see that there was a problem with our network configuration because we said in pfSense that this machine should use a static IP, not DHCP. So we need to configure our network manually. So we click Continue, we select Configure Network manually and we click Continue. Now here we specify the IP of our machine, so I will give it 192.168.40.10. The net mask is 24, which is the same as 255.255.255.0. We click Continue. The gateway will be the pfSense, so 192.168.40.1. The name server will also be pfSense because its purpose is to control everything, so 192.168.40.1. and we click Continue. We give a host name. I don't need a domain name, so I will let this empty. Give a name to the user, then choose a password and click on Continue. We choose Guided Use Entire Disk, then click on Continue. Select all files in one partition and click on Continue. Click on Continue to finish partitioning. Then we say yes to write the changes to disk and we click Continue. On software, we just click Continue and now this may take some time. Now click on Continue to reboot the system. Let's log in and let's open a terminal to see if the IP is correct. So ifconfig, and it is. Now let's move on to our server VM. So let's click on Create VM, we give an ID of 300 and the name will be storage. Then we click Next. Here we select the ISO, in my case it will be Ubuntu, then we click Next. Here we change the machine to Q35, the BIOS will be OVMF, then we check QEMU agent and we choose the EFI storage and that will be the local-LVM storage. Then we uncheck the pre-enroll keys and we click Next. On the disk, we change the storage to local-LVM and the disk size will be 30. Then we click Next, we give it 2 cores and we change the type to host. Then we click Next and we will give a memory of 4096. Then we click Next. On network, our VLAN tag will be 50 and we uncheck the firewall. We click Next and we click Finish. Now let's boot our VM to install Ubuntu. So we click on the VM, then Start, and we go to Console. Then we click on Try or Install Ubuntu, and here we will do the same as we did for the dev VM. So we choose Interactive Installation, then we click Next. We choose Default Selection, and then we click Next. Here we don't install anything, then we click Next. We choose Erase Disk and install Ubuntu, then we click Next. Give it a name and a password, then choose your location and click Install. And this may take a while, but when prompted to restart the system, do so. Now, as before, we need to remove the ISO image so the system can boot from the hard disk. So what we need to do is to go to Hardware, then we click on CD DVD drive and we choose Do not use any media. Then we click OK, then we shut down the VM and we start it again. Let's go to console, wait a little bit. Now, on the welcome prompt, we click Next, then we skip for now the Ubuntu Pro, we choose No to share system data, then we click Next and Finish. Now let's get a better view, so we go to Settings, Displays, and on the resolution, we change it to this, then we apply and we keep the changes. Now, if you open the terminal and run the command IPA, you will see that there's no IP address, so we need to manually say to Ubuntu what's our IP, gateway, and name server. So to do that, we need to edit the network manager file. So let's do it. So sudo nano etc netplan and the file, and we will add the following information. So basically we are telling that we don't have DHCP, that the address of this machine, so the IP address of this machine is 192.168.50.10. The gateway is 192.168.50.1, and after that, the name server is 192.168.50.1. Then we save the changes. Then we apply the changes with the command sudo netplan apply. And now, if you run the command IPA, we will have an IP and wired internet, which we didn't have before, so we can now update our system. So let's do it. Sudo apt update and sudo apt upgrade -y. Now let's restart the system. So, our VM is running well, but as you know, we didn't mount the HDD storage on this VM. So we need to do that to use the space to save files, images, etc. If we run the command lsblk, we see the space where we installed the VM, but we don't see the HDD-storage. So let's add it to our VM. So we go to hardware, then we click on add, then hard disk. Then we choose the storage that we want to add. In my case it is HDD storage. Now look at the available storage because we will add that quantity in the disk size space below. So as you can see, in my case I have 1.63, so I will give 1600 and then we click add. Now let's stop the machine and start the machine again. Now, if you run the command again, lsblk, you will see our new storage called SDB. So the first thing that we need to do is format the partition. So let's do it. mkfs.ext for dev SDB. Next, we create a directory where we will mount this partition, so make dir mnt storage. Then we mount the partition on that directory, so mount dev SDB on mnt storage. Now we confirm if the partition is mounted in the directory, so let's do it. df-h, and it is. Now we need to make this more permanent, so we will run a command that will give us the partition's unique identifier, and we will add it to the fstab file, so Ubuntu can mount this disk every time it boots. So to know the partition identifier, we run sudo blkid dev SDB. Now SDB because that's our partition. Also copy the output because you may need it when we add it to the fstab file. Now let's add the following string to the fstab file. So sudo nano etc fstab. On the last line, we add the following: the UUID, which stands for Universally Unique Identifier of the file system, and then we paste the identifier that we retrieved earlier. Next, we add the folder where we will mount the partition, which will be mnt storage, then the file system type, and you can see that by looking at the output that we saved, so ext4. After we write defaults, this tells Linux to mount this file system with the standard permissions like read, write, etc. Then we add a 0, and this will tell Linux not to make a backup of this file system. And lastly, we add a 2. This tells Linux, check this disk for errors at boot. In the end, you should have something like this, as you can see here. Now we save the changes and we exit nano. After this, we need to unmount the disk from the created mounting point. This is because we need to force Linux to reload the fstab settings. So if we don't unmount the disk, Linux might say that the disk is already mounted and not apply the fstab settings. So we run the following command: sudo unmount mnt storage, and then we force the new settings of the fstab file with sudo mount -a. Now it seems that we need to reload the systemctl, so let's do it with the command here above, and we run the command sudo mount -a again. Now let's quickly see if our storage disk is mounted by running the command df-h pipe grep storage, and it is, guys. Now we can power off our VM. Now, as you know, we will use the dev machines either through VNC or SSH. As you saw, VNC is already working, but SSH isn't. So let's start our dev VM2 machine and install SSH. Let's just confirm if we have SSH. We shouldn't have SSH because by default Ubuntu doesn't have SSH installed. So let's see, systemctl status SSH. So it seems that we don't have SSH. So let's install it. First we need to update the system. So sudo apt update. Next, we can install SSH, so sudo apt install OpenSSH-server-y. And now we need to enable SSH, so sudo systemctl enable --now SSH. And it's ready to use. Let's try to SSH into the VM using our host. Let me just verify if I have SSH enabled on my host. Okay, it seems that I have. Now, on the VM, I will see what IP the VM is using, which is this one. Then on my host, I will use SSH to connect to the VM. So SSH Sabatista, which is the user's name, at 192.168.30.53. Here we say yes, and we insert the password of our dev user. And guys, we are in, as you can see. Now let's see if this is working well. So I will create a file called hello.txt in the documents directory. So let's change into the documents directory, cd documents, touch hello.txt, lns, as you can see the file is here. Then using nano, let's write hello all, then we save and exit. Let's use cat to see the contents of the file. Okay, it seems everything is correct. Now on the host, using the SSH connection, we will check our location and change into the documents directory. lns, here we have the file that we created on the dev machine, cat hello.txt, and here it is, guys. It's working very well. Now, as you know, I will have Marcelo's PC accessing Proxmox, but I don't want him to have the same privileges that I have. He only needs to access the dev VLAN and the storage VLAN, and that's it. So I will add a new user, but with only the necessary privileges. So we go to permissions, then users, and we click add. The name will be Marcelo and the realm will be Proxmox VE authentication. Now we choose this realm because it strictly limits the new user to the permissions we assign within Proxmox, ensuring the safety of the underlying Linux system. Now we enter the password and we click add. Now that we have the user created, we can make a pool for each VLAN that the user is allowed to use, of course. Now these pools act as groups of VMs or containers, so instead of assigning permissions one by one, we apply rules to the pool, making it much easier to manage access. So we go to pools, we click create and we give a name. So I will name it dev pool and we click OK. If we go to search, we will have dev pool there. So we double click on it and we will add a member. We click on virtual machine because that will be the member, and we choose which VMs we want in this pool. In this case, Marcelo just needs the image as a member because he will create VMs from that image. And we click add. Now let's create another pool for the storage. So remember, these pools will be everything that Marcelo, in my case of course, can touch. So we go to data center, click on pools, click create and give a name. I will give it storage pool. Then on the left side we click on storage pool and add a member. Then we choose virtual machine and we choose the virtual machine called storage and click on add. Now let's apply the permissions to these pools. So we click on data center, then permissions, we click add, we select user permission and we choose the pool. So let's choose dev pool. We choose the user to whom these rules apply. In this case it will be Marcelo, and we choose what Marcelo's role is in this pool. I will choose the PVE VM admin. In front of it you can see what this role can do. Basically this role will let Marcelo create VMs, reboot, start and stop VMs. Now we click add. Now let's do the same for the storage pool. So we click on Add User Permission, we choose the pool, which it will be storage pool, then we choose the user, Marcelo, and this time the role will be PVE VM user. This role gives very limited permissions to Marcelo, and he will be able to access the VM, but won't be able to delete it or change its configurations. So we click Add. Now let's test Marcelo's account and see what he can access. So remember that my account had the VMs, Kali and storage. Let's log in with Marcelo and see what he can access. We enter its password, we choose the realm, which will be Proxmox VE, we log in, and guys, it's working. He can only access the dev image and the storage VM. And let's create our Proxmox account as well for daily use, so we can limit damage from mistakes or compromises. So as I told you before, we don't use the root account on Linux, we use this new account on Proxmox PVE. So let's do it. Let's log in back to the root account on Linux realm, and we go to users, then we click Add, we write the username, which will be admin in my case, then we change the realm from Linux to Proxmox, we enter the password and we click Add. Then we click on permissions, we click Add and we click on user permission. On path, we choose the / and this means that the user can work everywhere in Proxmox. On user, we choose the admin, the user that we just created, and on the role, we choose administrator, and we click Add. Now let's log out and log in with the admin's account on the Proxmox realm and see if it works. And here it is, guys, it's everything here. Now remember, always use this account for your day-to-day work and only use the root account for OS repairs and low-level fixes, okay guys? Let's jump to the last part of our physical home lab, the VLAN. As you know, I will use an entire old laptop for this VLAN. And this laptop has Ubuntu as its host and VirtualBox installed, where we will upload the vulnerable machines. Now, it's important to know that since our VLAN won't have internet access, we will download the vulnerable machine onto our computer, then transfer it to a USB and move it to the laptop, where we will install these vulnerable machines. But here's the thing, when we download these vulnerable machines, they are compressed in different archive formats. And to install them, we need to extract the files inside. So we have two ways of doing this. One is extracting the files in our computer and transferring those files into the USB and so on. And the second way is to install the extraction tools on the vulnerable computer and extract the files on that computer. So I will install some of those tools on the vulnerable computer, and after that, if I don't have a specific tool, I can extract the files on my computer. Next, install the following tools. I already have the tools installed, but if you want the same tools that I have, then run the command sudo apt install unrar, run that command. The second tool is sudo apt install unzip. The third tool is sudo apt install p7zip-full, and the last tool will be sudo apt install tar. These are the ones that I have, but if in the future there's any tool that you don't have, you can use your computer to extract the files. And let's begin the work on our vulnerable computer. So the first thing to do is connect the computer to its port on the switch. After that, we need to change the IP of the laptop to a static one. So we go to settings, then network, and on wired we click on the settings icon, then we click on IPv4 and we change to manual. Then we give the IP that will be 192.168.60.10. The net mask will be 255.255.255. 0 and the gateway will be 192.168.60.1 and the DNS will be 192.168.60.1. Now, this won't give us internet connectivity, and that's actually what's supposed to happen since we specified on pfSense that we won't have internet on this VLAN. Now let's open the terminal and run the command IPA, and as you can see, our IP is the correct one. Now the next step is to enable the DHCP server on the vulnerable interface. As you know, we do this because our machines will have the range specified in the alias, and pfSense is the one that will see that range and give IPs inside of that range to the vulnerable machines. So if you don't enable the DHCP server on this interface, then pfSense will have a hard time giving IPs, and pfSense may give the same IP to more than one VM, which would cause problems. So let's go to pfSense, then we go to services, then DHCP server, we click on vuln and we enable DHCP. Then on the address pool range, we give the range that we inserted on the alias, which will be 192.168.60.50 and 192.168.60.99. Then we save and we apply the changes. And we are ready to create the vulnerable machines on the vulnerable computer. So let's do that. The first step is to choose the vulnerable machine that we want to exploit. I will choose Metasploitable 2. So I will download the file directly into the USB on my computer. Now here we can see the default credentials for this machine. Okay, the file is downloaded. Now I will unplug the USB from my computer and I will plug the USB on the vulnerable computer. Now, on the vulnerable computer, I will move the file into the documents directory. After this, on the terminal, I will move into the documents directory and list the contents of that directory. Okay, by listing the contents of the directory, we can see that the file is zipped, which means that we need to use the tool unzip to extract the files. So let's do that. So unzip and the file. Now let's create a new VM on our VirtualBox. So we click on New, we give a name, so Metasploitable 2. On the OS we choose Linux. OS distribution we choose Other Linux and we click Next. We increase the base memory to 1024 and we leave the rest as it is, because remember that we don't need a lot of specs, just enough to run the machine. And now we click Next and we click Finish. Now I tried to upload the VMDK file, but I had some problems. So to solve this, I converted the VMDK file into a VDI file. So I will show you how to do that in case that you have the same problem as I did. So let's go change into the directory that has the Metasploitable files. Okay, now let's run the following command to convert the VMDK file into a VDI file. I will just explain this very quickly. So the vboxmanage, it's the command line management tool of VirtualBox. Clone HD tells vboxmanage to convert a hard disk image. Metasploitable.vmdk is the file that we are converting. The VirtualBox /VMs, it's the directory where every machine created in VirtualBox is saved. When we created the Metasploitable machine in VirtualBox, the information of this machine was stored in this directory. Also, the // is used to tell the system that the space is part of the folder name, not a separator. Then we have Metasploitable2.vdi, and this is the new file name that we chose for the converted disk with the .vdi extension. And the last part of the command, so -- format VDI, tells VirtualBox to create the new disk in its native VDI format. We can't simply give the file a new extension like the .vdi because the underlying VMDK data has to be properly converted into the VDI format. And it's time to upload the file, so we go back to the VirtualBox and we go to Settings, then Storage, and under Controller, if you have any file, right click on it and remove the file. Then click on Controller IDE and click where it says Add Hard Disk. Then we click on Add, and as you remember, we go to the directory where we saved our our converted file. In my case it was home, then VirtualBox VMs, and choose the metasploitable2.vdi file. Then we click choose, and now before we click OK and launch the box, we need to tell VirtualBox that this VM will use a different type of network. So we go to network and we change from NAT to bridged adapter. This will tell VirtualBox that this VM will use the same physical network as our computer. Now we can click OK and start the VM. To log in, remember that the username was msfadmin and the password was also msfadmin. And as you can see, we are in, guys. So let's see what IP this machine has. Let's run IP A, and as you can see, the IP is 192.168.60.53, which is correct. It's inside of that range that we defined on pfSense. And now let's test the rules that we applied on pfSense to this vulnerable machine. So let's use our Kali to make some tests. Let's power on our Kali VM. Now we go to the terminal and let's ping our vulnerable machine. So 192.168.60.53. And as you can see, we can ping the vulnerable VM. Now let's try to ping our Kali on our vulnerable VM. This isn't supposed to work because we gave permission to Kali to ping vulnerable machines, but we blocked vulnerable machines from pinging Kali. So let's ping 192.168.40.10. And we can't, guys, so this is working very well. And lastly, let's run an nmap scan to see if this is working well. So nmap-a and let's scan our vulnerable machine. So 192.168.60.53. And we have a great output with a lot of things to exploit. Nice work, guys. And the last thing in this video is about the logs. Remember that on the block rules we enabled logs. This means that every time someone tries to do something blocked by our rules, pfSense will save that attempt. So to access the logs, we go to status, then system logs, and we choose firewall. Here we can see the attempts against our devices. As you remember, we tried to ping our Kali with our VM, and because we have a rule that blocks that attempt was saved in these logs. Now, if you want to shut down pfSense, you go to diagnostics, halt system, and halt system. And that's it, guys. I hope you liked this video. I know it's a little bit big, but I thought it would be better for you to have access to the full video instead of giving you small parts. So, if you like this video, please give it a thumbs up. If you have any questions, please leave those in the commentary section down below and subscribe for more content like this. See you next time. Stay curious and stay safe. Bye bye!